right, guys, we are going to talk more about surface area again, but this time we are going to do surface area of pyramids. And we're doing that on 121 and 122. 121 again is sort of the intro page, and then 122 is where it's really going to go. But it's okay to think of like the pyramids when you think of a pyramid, because that's kind of what a pyramid in geometry is. It's sort of like this flat shape that comes up to a point. And so, yeah, it's legit to think about the pyramids when we're talking about a pyramid. So, I didn't know if that was obvious or not. If we turn to this page here, we're talking about surface area today of pyramids. Again, we want to try to think back to when we were looking at the net. So when I have a pyramid, three-dimensional shape, but then I unfold it into all of its parts, what you sort of get is this one single shape in the center with triangles coming down from all sides of it. So a pyramid is something that has one base and then triangles around. So now that I'm writing that, I wonder if I actually put that for prisms. Let me maybe go back. So for prisms, we said two parallel and congruent base shapes, but then and rectangles around. I always feel like that's good to remember because they do have different stuff around, and that's kind of important. So again, we name a pyramid kind of like we name a prism. Whatever that one base is, that's how we base our name of our pyramid. So in this pyramid here, I can see I have triangles all the way around. Like those are the things making up the point. And I have a square on the bottom. So this would be a square pyramid. Now with pyramids, kind of the tricky one are the triangular pyramids because they're kind of all triangles. So sometimes you can pick whichever triangle you want. I'll just kind of go with the bottom here. So because this bottom is a triangle, it'd be a triangular pyramid. Those ones are kind of like the ones with the rectangular prisms where it's like, which rectangle do I pick since I have rectangles around? Kind of doesn't matter as long as you're consistent. And then as the shapes get bigger, you can have bigger type pyramids like a hexagonal pyramid. So base shape is a hexagon. You could have a trapezoidal pyramid. That'd be weird. Could you? I wonder if that would come together. I feel like it could. It'd be weird, but it could. And so when we're talking about surface area and lateral area, just like we did before, it's a little different because so lateral area is maybe if I just want to know the stuff around, and the stuff around here is pyramid. So when we're finding the area, or is a pyramid, is a triangle. So when I'm finding the area of all those triangles, and there's like maybe 4 of them if it's a square, or 6 of them if it's a hexagon, but it is a triangle. And so I feel like this formula does sort of make sense. We have half, because like whenever I'm finding the area of a triangle, we always have that half base times height. But because there's a lot of them, we end up actually doing the perimeter, because they're all coming around the perimeter of that base, times this fancy L thing that stands for the slanted height. So like the slanted height, it's kind of just that. Like normally when I have a height, it's a straight up and down height. I think this is the best one to see. But a slanted height is the one that's slanted. It's the one that's, slanted, diagonal. And like you might think, why can I use that as a height? Well, if you think about this triangular flap coming down, like the slanted height is actually the perpendicular height of that triangle there. And you have 4 of those triangles, so that's kind of why we're doing the perimeter. So that kind of takes care of all of them. So hopefully that sort of makes sense. Then once I have that lateral area, it just makes finding surface area so much easier because surface area is all the stuff around, so the lateral area, plus the area of the base, which in this case there's only one base. So one base plus the lateral area, so half PL. And then the base area is just dependent on the base shape. So if my base shape is a square, we're going to do base times height. If my base shape is a triangle, we'll do half base times height. If my base shape is a hexagon, we'll do half apothem times perimeter, or if it is a circle, aka a cone, like an ice cream cone, you'll do pi r squared. So it just depends. We'll talk about volume in a different one. So jumping over here, that lateral area, again, sorry, kind of got cut off, is that half PL, where P is the perimeter of the base, and then L is the slanted height. Okay, so in this case here, like perimeter of the base is like all the stuff around the square base. The slanted height is not this height, because that is the perpendicular one. The slanted one would kind of need to be drawn in right here. And it's the height along this slanted triangle. Okay, then when we're finding the surface area, we're going to do the area of the base plus our lateral area, so half PL. So lateral area is right there. But then here we want the area of the base shape, whatever it is, in this case a square. Okay, so same thing is true when my base is a circle. So lateral area, geez, the pi r feels like it's wrong, but it's not. Let's talk about some simplifying. So lateral area is normally half perimeter times the slanted height. Perimeter of a circle, though, is really circumference, which we can think of as d pi, but we can also think as 2 pi r. So if I replace the perimeter with 2 pi r, every time what always happens is that the half and the 2 go away, and so we're sort of just left with pi r. Okay, so r is my radius, and then L is still at slanted height, which again, in this picture here is not that one. It's kind of this one, because that's the slanty height. Also, we'd want to get that radius drawn in there. Doop, doop, doop. Like that. And then if we want to find our surface area, it's still going to be area of the base plus my lateral area, which in this case is pi RL. Pi RL kind of sounds like TRL, but you guys probably don't remember what TRL is. You're so young. So this is our lateral area, and this is, again, area of the base. But in this case, it will always be pi r squared because my base shape is a circle. All right, let's just try a whole bunch. So looking at this first one here, the base shape has to be the square. And I do know that it's a square because they're showing me each side is 10. So when we want to find that lateral area, our formula for that is half PL. So we'll do half times perimeter of the base. So the perimeter of this square is going to be 10 plus 10 plus 10 plus 10, or really 4 times 10. And then the slanted height, oh, I don't know if they're showing me what the slanted height is. What they are showing me is this right triangle in here that does have a 60-degree angle in it. But it kind of feels like I don't know any of those sides. But truly I do, because the thing is, this right here is an apothem of your square. Or really it's half the height of your square, because that's what an apothem is. So this is really 5. And so if I think about my 30, 60, 90 right triangle here, I know that the short side is 5. And so the long side would be 5 root 3, although I don't need that height. I want the slanted height, which is actually the diagonal, which is actually double this. So 10. That's kind of convenient. And so my slanted height is 10, And now that I have all my numbers filled in, I can take half of whatever I want because we're just multiplying all the things. So half of 4 is 2 times 100 for 200 units squared. We're back to units squared because we're doing area. So when I then want to find surface area, we're going to do area of the base plus half PL, which is just this lateral area here, which was 200. And so then when we think about finding the area of the base shape is a square. And so I find the area of that by doing side squared because I do know the side. And it's 10. So 100 plus 200 is a surface area of 300 units squared. Alrighty, on to the next one. Looking at this one here, hopefully it makes sense to you that the base shape would sort of have to be that bottom. And the reason that it has to be is because they're showing me this slanted height right here. And so I definitely want to use that slanted height. So if I take that as the base shape, if I want to find the lateral area, we're going to do half PL. So P is perimeter of the base. And the perimeter of this triangle, I need to add up all the sides, but it kind of feels like I don't know this one. Although I do, because it's a right triangle. And so I can find this third side. And 3 and 4 and 5 are Pythagorean triple. And so to find that perimeter, we're going to add all those up. So 3 plus 4 plus 5. Then times that slanted height, which my slanted height, they're just straight up showing me, is 6. So that's super nice. So we're going to want to add up what's in parentheses for 12. And then we can take half of whatever we want. And so we end up with a 36 units squared for that lateral area. Then when I want to find the full surface area, we're going to do area of the base times half PL. So half PL is just this lateral area here was 36. And then thinking about finding the area of this base shape, the base shape is a triangle. So the way I find the area of that is half base times height. And the base and height of the triangle have to come where the 90 meets. So the 3 and the 4. So half times 3 times 4. We'll take half of 4. So 6 plus 36 is 42 units squared for that surface area. Alrighty, let's move on to this one here. So finding the lateral area, we're going to do half PL. However, because the base shape is a circle, and finding the perimeter of a circle is really circumference, or 2 pi r. What happens is the half and 2 go away, so we're really just going to have to do pi RL. I kind of just always remember this. Like, I know I wrote this other one on the front here, but like in my brain, I don't want to have to remember kind of 2 different formulas. Like, I just want to like remember the one and fill it in. So we got pi times the radius, which unfortunately 9 is not the radius. 9 is the diameter. So we're going to have to do 9 over 2, or half of 9, and then times the slanted height. Ugh, they also didn't give me that. Rude. Guess you're going to have to do the Pythagorean theorem. Because the thing is, right here I have a right triangle where I can see that the true height is actually 10, and then that radius was 9 over 2. And so we're going to do over here a little side math and do this 10 squared plus 9 over 2 squared equals the hypotenuse squared, or my slanted height squared. Let's change it to L. So we'll have 100 plus 81 over 4 equals L squared. And so if I actually change this to 400 over 4 so that it's still 100, but I can add it to this one, we'll have 481 over 4. And then we'll want to square root that, which actually leaving it like this, I think the square root of 41 is actually a thing. Oh my goodness, if it was, I would be so happy because the square root of 4 is a thing. Let's see, 481 square rooted. Dang it, it's not a thing. Not a thing. Well, all right, so for our lateral height here, we're going to have square root of 41 over 2, because I'm going to square root that 4. And that is going to go in right here for lateral. Then what I have here is just a whole mess. My denominator is 4. My numerator is kind of this 9 square root of 481, which could definitely be simplified pi. But like, since I'm going to have to square root this nastiness, I think I'm just going to get an approximate answer on this one. So I'm going to like multiply by pi and everything. So let's just try to keep as much of the decimal as possible. So if I take the square root of 481, we get this number here. And then we just need to do all these things to it. So it's being multiplied by 9. It's being divided by 4. And then it's being multiplied by pi. And so we get this approximate lateral area of 155.03 units squared. You hate to see it, but sometimes it just happens. Now for surface area, luckily some of the work is already done. So surface area is area of the base plus half PL, which we already know what half PL is. It's that number right there, which I'm going to leave on my calculator because, like, why not? Then for area of the base shape is a circle, so pi r squared, which remember r was that 9 over 2. And so we'll have 9 over 2 squared, which is 81 over 4 pi. And then we're going to add that to all this. Now, that is maybe going to be tricky to keep that on my calculator. So I won't. We already have this rounded here. And so I'll do 81 over 4 and then multiply by pi. And then I'll add my rounded lateral area. So 155.03 to get this approximate surface area here of 218.65 units squared. Womp womp. I always like to keep exact if I can, but truly, like, it's just because I have like this math brain. Like, truly, if you need to find the surface area of something, you're not going to keep it exact. Like, you need to, like, you want to keep it exact, but the thing is, like, actual measurements don't really work that way. Like, you need to cut the wood or cut the thing somewhere, so you're going to have to approximate it. Alrighty, last one. If we want to find our lateral area, we're going to do half PL. However, because my base shape is a circle, the perimeter of that is really circumference, 2 pi r, and so the 2.5 just go away. So this reduces to pi RL. So my radius, oh my goodness, they didn't give me my radius again. And it's not like they even gave me my diameter to use. What they did give me was this right triangle right here, which I have the hypotenuse of, and they're showing me that it's a 30-degree angle here. So on my 30, 60, 90, because I have the hypotenuse, the short side will be half, and the long side will be half root 3. I don't really need that height, but I knew it, so why not? So now I know that my radius is 6, and the slanted height they gave to me, that was 12, so that was super nice of them. So we get 72 pi as unit squared as my lateral area. And so then to find surface area, we're going to do area of the base plus half PL, or that lateral area there. So the 72 pi can just come here. And then when we find the area of the base shape is a circle, so pi r squared. And the radius was 6. So 36 pi plus 72 pi is 108 pi units squared. I'll see you in the volume one.